Imagine, for just a second, running a massive global physical product business straight from your laptop.
Right, like sitting at your kitchen table.
Exactly. You're at your kitchen table or maybe, a coffee shop somewhere, and you have zero warehouses.
Yeah.
You own exactly zero delivery trucks, and you have zero manual laborers on your payroll.
Which is kind of hard to even wrap your head around.
It totally is, because with just a few clicks on a dashboard, this entire fleet of, drones, humanoid robots, autonomous trucks, they all just instantly spring into action.
Yeah.
They handle every single step, like picking up products on a factory floor in Vietnam, navigating the ocean freight, clearing customs, right down to gently dropping a package onto a customer's doorstep in Kenya.
And you never even touch the product.
Never once. You never touch the physical product. You just orchestrate it.
I mean, it sounds like a pure simulation, like an incredibly complex resource management video game.
Right.
Except the outputs are happening in the real physical world.
Yeah.
You're manipulating actual atoms across thousands of miles.
Yeah, and the crazy part is the foundation for this reality was laid on May 4th, 2026. So welcome to today's deep dive.
Glad to be here.
Today we are looking at the dawn of what's being called the physical AWS era. We're going to examine the sudden, dramatic convergence of global logistics, artificial intelligence, robotics, and, honestly, the massive infrastructural shifts required to support a completely frictionless physical economy.
And I think the premise here requires us to really look past that surface-level idea of just, we get faster shipping now.
Right, it's way bigger than that.
It is a fundamental re-architecting of the global physical economy. I mean, we are looking at a shift from an economy constrained by human labor and fractured infrastructure to one driven entirely by physical AI.
Yeah, it's like the abstraction of the physical world into a digital interface.
Exactly.
So, okay, let's unpack this. To really grasp the robotics and these insane global routing algorithms, we have to understand the platform they operate on first, right?
Right. The architecture that makes all of this possible didn't just appear out of nowhere.
No, but it was fully unleashed with this one announcement: the launch of Amazon Supply Chain Services, or ASCS.
Yeah, that was the catalyst.
Because they essentially opened up their entire end-to-end global logistics network: ocean freight, air freight, grain transportation, rail, the fulfillment centers, parcel shipping, all of it.
All of it. Open to third-party businesses of literally any size.
Right, so from a one-person startup in the garage to massive companies like Procter & Gamble or 3M.
And the genius of that move, honestly, isn't even the physical assets themselves. It's the unified console.
What do you mean by that?
Well, it's the API-ification of the global supply chain. Historically, if you were a business owner, trying to move goods internationally, you were dealing with a wildly fragmented ecosystem.
Oh, totally. A complete mess.
You had your freight forwarders, then you had separate drayage companies to move containers from the port to a railhead.
Right.
Then different 3PLs for warehousing, and yet another carrier for the last mile delivery.
And every single one of them had their own software, right?
Exactly. Their own software, their own data silos, and of course their own profit margins stacked on top of each other.
Yeah, everyone takes a cut.
Right. So ACS just consolidated all of that into a single unified inventory pool that you can access via open APIs.
I mean, the parallel to the digital world is just completely transparent here. It's AWS, but for physical stuff.
It's exactly the same playbook.
Like, if you think back to the early 2000s, building a software company meant massive capital expenditure, right?
Buying servers.
You had to literally lease server space, rack the physical hardware yourself, manage the cooling.
Provision for peak traffic.
Yes. And if your app went viral, your servers just crashed. Then AWS came along and essentially said, don't buy the server, just rent the compute.
Pay for exactly what you use.
Right, and you scale infinitely with an API call. And what we're seeing now is that exact same playbook, but for atoms instead of bits. You don't buy the warehouse.
You don't lease the trucks.
Exactly. You rent the physical space and the movement on demand.
And just like AWS, Amazon didn't build this massive infrastructure initially just to sell it as a service to other people.
No, they had to build it for themselves.
Right. They spent decades building this hyper-optimized supply chain just to survive their own crazy retail delivery promises.
The 2-day prime shipping monster they created.
Exactly. And they sort of tested the waters with Fulfillment by Amazon, or FBA, right?
Yeah, FBA was huge.
Because they realized that integrating third-party inventory made their own flywheel spin faster. FBA proved the model. I mean,
Yeah.
sellers saw nearly 20% higher sales simply because the logistics were less terrible.
Right, the conversion rates jump when the shipping is reliable.
Yeah. So ASCS is really just the terminal velocity of that exact strategy. They took their internal nervous system and just made it public.
But, okay, if you open that nervous system up to literally everyone, from a solo entrepreneur to American Eagle, the volume of physical goods entering the network must just be
Oh,
astronomical.
it's unprecedented.
And you can scale digital compute by just, plugging in more server racks, but scaling physical movement has always hit a really hard wall, which is human labor.
The physical constraint,
Right, you can't just spawn a million warehouse workers out of thin air when demand spikes for the holidays.
which is the exact bottleneck that forced the shift toward what we're calling physical AI.
Physical AI.
Right.
Yeah.
And we need to be clear, this isn't just about throwing more mechanical arms into a warehouse.
Wait, okay, so push back on that for a second, because a conveyor belt is automated, right?
Sure.
How is a robot with physical AI actually any different from the dumb machines we've had in factories for, like, a century?
It's a great question. So traditional automation is rigid. Think of a car manufacturing plant from the 1980s.
Okay, giant sparks flying, robotic
Right,
arms.
you have a massive robotic arm locked inside a cage, and it swings a welding torch along a mathematically perfect arc every single time.
Over and over.
Exactly.
Hmm.
But if the car chassis is misaligned by even 2 inches on the belt, the robot still welds the empty air.
Oh.
Or worse, it crashes into the metal and halts the entire assembly line.
Because it doesn't actually know what it's doing.
Exactly. It has no awareness.
Mm-hmm.
That kind of automation requires an incredibly structured, perfectly predictable environment, like a train on tracks.
Okay, and a global fulfillment center is definitely not a predictable environment.
It is pure chaos. I mean, you have millions of distinct SKUs, all with different weights, shapes, fragilities,
Mm-hmm.
and they are constantly moving.
Right?
This is where physical AI changes everything. It's the integration of perception, reasoning, and learning into the embodied robotic systems.
So they can actually perceive the chaos.
Yes. For example, look at the Vulcan system mentioned in the sources.
Oh, the picking robot.
Right. Vulcan is a robotic pick-and-place system, but instead of being hard-coded to move to specific coordinates, it utilizes a combination of advanced computer vision and tactile sensing.
So it's actually feeling its way through the problem.
Exactly. Imagine it reaches into a messy bin. Inside, there's a heavy steel wrench, a delicate glass bottle, and a soft cotton t-shirt.
It obviously has to handle all three of those totally differently.
Right. And the engineering behind how it does that is fascinating. The vision models, which are essentially these massive transformer networks trained on millions of hours of operational video, they first identify the object.
So it looks and says, that's a glass bottle.
Yeah. And then the AI calculates the center of mass and the optimal grasp points. But the real breakthrough is the variable compliance at the end effector.
The end effector being the robot's hands.
Right, its fingers. They are equipped with these high-resolution elastomer sensors.
Okay.
So as it grips that glass bottle, it actually measures the microscopic deformation of the sensor surface to calculate slip and friction in real time.
Oh, wow. Wait, really? It feels the glass slipping?
Yes. And it applies exactly enough force to lift the bottle without shattering it. It's reasoning about physical material properties on the fly.
That is insane. And so while Vulcan is solving that micrologistics problem of just grasping things, you have other systems handling the macrologistics, right? Like Sequoia.
Right, Sequoia's handling the warehouse floor itself.
Yeah, from the sources, Sequoia is moving the actual storage dynamically. We're talking about AI visually mapping and optimizing inventory placement to make retrieval 75% faster.
75%, that's a massive efficiency jump.
It's like it's defragmenting the physical space the same way a computer defragments a hard drive. It's constantly moving highly requested items closer to the outbound flow.
And that data doesn't just stay in the warehouse. It feeds directly into the routing layer, into systems like Deep Fleet.
Right, the autonomous trucks.
Exactly. When you have autonomous trucks moving between these fulfillment centers, the AI isn't just looking at, Google Maps traffic patterns.
Right.
It's predicting the physical state of the entire network. So it knows that a sudden spike in demand for winter coats in Chicago means it needs to preemptively route empty autonomous trailers to a specific hub in Ohio.
So it's moving the trucks before the items are even fully ordered.
Yes. By anticipating the physical flow, Deep Fleet optimizes drive times by about 10%.
Which sounds small, but at a global scale, a 10% reduction in drive time is just an unimaginable savings in fuel, maintenance, and, capital depreciation.
Absolutely. And this brings us to the core macroeconomic engine driving all of this, which analysts call the deflationary flywheel.
Right, the flywheel. Let's break that down for people.
So every time Vulcan successfully learns how to pick up a new, weirdly shaped product without dropping it, that learned behavior is instantly pushed to the entire million-robot fleet via a cloud update.
So one robot learns it, and suddenly a million robots know how to do it.
Exactly. The network becomes objectively better overnight, and the mechanics of this flywheel are ruthless.
How so?
Because the logistics become cheaper and more reliable, the barrier to entry collapses. More businesses plug their inventory into ASCS.
Right, the solo entrepreneur at the kitchen table.
Yeah. That pushes a wider diversity of physical goods into the system, which generates a massive influx of edge case data for the AI.
Weirdly shaped objects, basically.
Yeah. The physical AI ingests that new data, improves its predictive models and tactile reasoning, which further drives down the marginal cost of moving a package.
Cost goes down, volume goes up.
The AI gets smarter, and the cost goes down again. It's a continuous loop.
And the nature of the cost itself completely flips, doesn't it? Under the old model, logistics was a variable labor cost.
Completely.
Like, if you wanted to ship twice as many boxes, you had to hire twice as many humans. You had to deal with shifts, overtime, injuries, union negotiations, turnover. Now, the cost structure is entirely different.
Right, because the bottleneck isn't human labor anymore. The new bottlenecks are capital expenditure and energy capacity.
So building the robots and powering them.
Exactly. If you need to double your throughput, you just manufacture more robots and ensure the local grid can supply the megawatts required to charge them.
You're trading the unpredictable inflationary cost of human labor for the predictable depreciating cost of hardware.
And the marginal cost of electricity. This fundamentally changes the economic ceiling of global trade.
Okay, so the warehouses are hyper-optimized. The autonomous trucks are moving the bulk freight between these massive hubs. But the ultimate test of any supply chain is the last mile, right?
Always. The last mile is the hardest part.
The friction always skyrockets the closer you get to the customer's front door, because you can't put a 2-ton autonomous delivery van on a quiet residential street just to deliver a phone charger.
No, it's incredibly inefficient.
And this is where the network leaves the ground entirely. Here's where it gets really interesting.
The aerial layer.
Yes. Amazon Prime Air and the massive deployment of autonomous drones. The scale they are targeting in the 2026 sources is intense. We're talking 500 million drone deliveries annually by 2030.
And that's operating from expanded hubs all across the U.S., plus a commercial launch in the U.K.
Right. And the flagship hardware doing this is the MK30 drone. It's quite the machine.
Yeah, what are the specs on there again?
So it carries up to a 5-pound payload, which covers a ton of standard e-commerce stuff, accessories, meds, that kind of thing. It cruises at about 73 miles per hour and has an operating radius of roughly 6 to 8 miles.
That's fast.
Yeah. But what's really compelling to me is that it can operate in light rain and sustain winds over 20 miles per hour. Like, it's not a delicate toy you fly in your backyard.
Right. It's a hardened piece of physical infrastructure.
Yeah.
And it has to be because of how it fits into the broader routing architecture. You can really think of the supply chain like internet data routing.
Right, exactly. You have the massive submarine fiber optic cables carrying petabytes of data between continents.
Yeah.
In the physical world, those are the ocean freighters and the autonomous long-haul trucks on the highways. They handle the massive, dense packets of bulk inventory.
But to get that data into your phone as you walk down the street, you use localized Wi-Fi or 5G.
Exactly. The drones are the physical equivalent of a 5G network. They bypass ground congestion entirely to handle these time-sensitive low-weight packets.
And the routing algorithms treat the drone fleet as just another protocol. When an order drops into ASCS, the system instantly calculates the payload weight, the delivery window, the local weather conditions.
It looks at all of that in milliseconds.
Yeah, and dynamically decides whether that specific package goes into an autonomous ground van or gets strapped to an MK30 drone. It's a multimodal symphony orchestrating the most energy-efficient path for every single atom.
But, the hardware isn't the primary reason this suddenly became viable in 2026. Drones have existed for years.
Right. We've seen drone delivery test videos for a decade.
Exactly. The massive unlock here was actually regulatory. The FAA's Part 108 proposals.
Ah, BVLOS.
Right, beyond visual line of sight.
That regulatory shift changes the unit economics entirely. because for years, commercial drone operations were heavily restricted by this one rule. A human pilot, or at least a visual observer, had to physically maintain a line of sight with the aircraft at all times.
Which completely defeats the purpose.
Totally. If you have to pay a human to stand in a field and watch a drone fly to a house, you have completely destroyed the economic advantage of automation.
Yeah, it's just a very expensive remote control car at that point.
Exactly. So Part 108 provides the regulatory framework for these machines to fly autonomously for miles, relying entirely on onboard detect and avoid technology.
And the detect and avoid systems are incredible now. They aren't just broadcasting GPS coordinates to each other. They're actively fusing data from multiple sensors.
Like LiDAR and radar.
Yeah, LiDAR, radar, and optical cameras all working together to build a real-time 3D map of the airspace.
Which is necessary when you have hundreds of these in the air.
Right.
Yeah.
Like if a medical helicopter unexpectedly enters the flight path or a tree branch is swaying in the wind, the drone's onboard edge compute recognizes the anomaly and instantly calculates an evasive trajectory.
It's basically bringing the principles of autonomous driving into a three-dimensional high-speed environment.
But as impressive as the aerial layer is, it actually highlights a really profound limitation in the system. Drones own the sky, right?
Right.
Autonomous trucks own the highways. Wheeled robots own the perfectly flat, mathematically mapped warehouse floors. But the vast majority of the physical world wasn't designed for machines.
It was designed for humans.
Exactly. It's messy. It has stairs, curbs, weirdly shaped doorknobs, narrow hallways, unpredictable clutter.
Right. A wheeled robot is entirely defeated by a 6-inch step leading up to an apartment lobby.
So if the goal is a truly frictionless, end-to-end automated supply chain, how do you cross that final unstructured gap?
Well, this is where the integration of humanoid robotics becomes a strategic inevitability.
Humanoids. This is the sci-fi part.
It feels like it, yeah. Specifically, we're looking at the deployment of platforms like the Tesla Optimus Gen 3.
Okay, but just to be clear, based on the sources, there's no formal partnership explicitly announced between Amazon and Tesla for ASCS yet, right?
Correct. No formal partnership is on the books. But the technological convergence the sources outline is just too powerful to ignore. The Optimus units are hitting pilot production with a target price point of $20,000 to $30,000 at scale.
Which is roughly the cost of a cheap compact car.
Yeah. But the physical form factor, having 2 legs, 2 arms, and human-like hands, isn't even the most important part.
Wait, really? I thought the whole point was that they look like us so they can use our spaces.
That's the hardware enabler, sure.
Hmm.
But the real magic is the cognitive architecture inside the robot. They're leveraging the FSD AI stack.
Full self-driving from the cars.
Exactly. The transition from heuristic coding to end-to-end neural networks is the absolute breakthrough here.
Can you explain heuristic coding?
Yeah, so with traditional robotics, engineers had to explicitly code rules. They'd write a script that says, if the camera detects a box at exactly these coordinates, extend arm exactly 14 inches, apply X amount of pressure.
It's very rich.
Incredibly brittle. If the box is rotated slightly, the robot fails. End-to-end neural networks bypass all of that explicit coding.
So how does it learn?
You feed the system millions of hours of video data showing humans performing tasks, picking up boxes, climbing stairs, opening doors. The transformer model maps the raw pixel data from the robot's cameras directly to the joint torques required to replicate the action.
It's learning by observation, not by instruction.
Precisely. So when a humanoid robot encounters an obstacle it has never explicitly seen before, say, someone left a bicycle blocking a walkway, it doesn't just freeze up because there's no bicycle rule in its code.
Right.
It relies on its foundational understanding of 3D space, which it learned from the FSD system navigating busy, chaotic intersections, to simply step around it.
The implications for ASCS are just massive.
Yeah.
Because humanoids fill the gaps where fixed automation fails.
Absolutely.
Like imagine a shipping container arriving at a port. During the ocean voyage, a storm caused the perfectly palletized boxes to shift and collapse into a random, chaotic pile inside the container.
Which happens all the time.
Right. A wheeled warehouse robot cannot navigate that uneven surface of fallen boxes. And a rigid robotic arm can't calculate how to untangle the mess without crushing something.
But a humanoid can.
Right. A humanoid can walk in, visually assess the pile just like a person would, and carefully unstack the boxes, restoring order to the system.
But, okay, let's ground this in reality for a minute.
Please do.
Because the vision of 1 million humanoids seamlessly navigating our cities is incredibly compelling, but the friction of actually deploying this is staggering.
Yeah, this sounds amazing, but surely there are hurdles. We aren't going to have a million humanoids walking around tomorrow.
No, definitely not tomorrow. What's fascinating here is the sheer scale of the deployment hurdles, starting with safety and liability.
Safety, right.
Bipedal locomotion walking on two legs is inherently unstable. It's essentially a series of controlled falls.
That's a mildly terrifying way to phrase it, but true.
Yeah, so if an Optimus unit loses its balance on a wet loading dock and falls onto a human worker, the liability is catastrophic. You have years of safety certifications, union considerations, and edge case testing required before these operate alongside the general public.
Not to mention the hardware supply chain bottlenecks.
Oh, the components.
Yeah. To build millions of these, you need a staggering volume of highly specialized components. High-torque electric actuators, harmonic drives for the joints, advanced tactile sensors.
And high-density battery packs.
Right, batteries that can power complex edge compute and heavy physical labor for a full 8-hour shift. The world currently just doesn't manufacture these parts at the scale required for millions of units.
Which is why the rollout is going to be heavily phased. The Sources project, we're looking at meaningful, high-volume pilots in highly controlled, geofenced environments between 2026 and 2028.
So they'll be kept away from the public at first.
Exactly. Confined to specific zones within fulfillment centers, handling the irregular tasks that break the standard automated flow.
And the business model surrounding this is fascinating too, because it's highly unlikely Amazon would just drop billions to buy a million robots outright from Tesla.
No, that's way too much capital risk.
Right. We're looking at robotics as a service, or RAS.
Yeah.
Tesla provides the physical hardware and the edge inference, maintaining the fleet essentially like a utility company. Meanwhile, a platform like AWS powers the massive simulation environments.
The digital twin.
Exactly, digital twins of the warehouses. The robots run millions of virtual scenarios overnight in the cloud to learn new tasks before attempting them in the physical world. It's a complete blending of digital cloud computing and physical edge hardware.
It creates this hyper-localized intelligence. But this hyper-localization brings up the most critical tension in this entire shift.
What's that?
Well, everything we discussed so far. Primary drones navigating the suburbs of Chicago, Vulcan arms in pristine Ohio fulfillment centers, humanoids learning in controlled environments, it all assumes a baseline of high-quality infrastructure.
Ah, first world infrastructure.
Exactly.
Yeah.
But if ASCS is going to be the API for global commerce, it has to actually function globally.
Right. A platform isn't truly global if it only works in North America and Western Europe.
Right.
Like, if you take an autonomous delivery van that performs flawlessly on a freshly paved, mathematically mapped street in Arizona, and you drop it into the hyperdense, chaotic, unmapped traffic of a megacity in Southeast Asia.
You'll completely freeze.
Yeah, the AI will be overwhelmed by the lack of structured data.
This is where the strategy shifts toward the hub-and-spoke model and what the sources call hybrid autonomy.
Hybrid autonomy, break that down.
So Amazon is pouring capital into massive gateway hubs in highly strategic global choke points, places like Singapore, Dubai, Rotterdam, Panama, and Santos.
So these are the main entry points for entire regions.
Right. These are state-of-the-art, fully automated nodes that receive the massive intercontinental freight. The long-haul ocean and air layers are highly controlled.
But then the goods have to leave those hubs.
Exactly. And as the goods flow out from those gateway hubs into secondary cities and emerging markets, the infrastructure degrades quickly.
So they can't use the fancy autonomous vans.
So they don't force the robotics where they don't fit. Instead, they rely on local franchise partners deeply embedded in the local geography.
Ah, so using people who actually know how to navigate the chaos.
Yes. And the ASCS software seamlessly integrates these partners. An algorithm might route a package via an automated rail line from the gateway hub to a regional center, and then hand it off to a local partner operating a fleet of cargo bikes or river barges.
That's wild. So you have robots and AI handing a package to a guy on a river barge.
Exactly. And the entire chain remains visible and trackable within the ASCS API, even if the last mile is executed by a human on a motorcycle navigating a favela.
So it abstracts the local complexity for the seller. Speaking of complexity, while the physical routing is incredibly difficult, the bureaucratic friction of crossing borders is often what actually kills global commerce for small businesses.
Oh, absolutely. The paperwork.
Yeah. If you're a small manufacturer in Vietnam, trying to sell directly to a consumer in Mexico is a total nightmare.
You have to secure customs bonds, navigate wildly varying tariff structures, ensure your product classification codes are Absolutely perfect.
And screen the buyer against international sanctions lists. It usually requires armies of lawyers and freight forwarders just to make sure you don't accidentally commit a felony.
Right. So the ASCS platform abstracts all of that regulatory friction into the software layer.
How does it do that?
They are deploying specialized AI to act as a universal customs broker. The system ingests commercial invoices, uses large language models to read the product descriptions, and automatically assigns the correct harmonized system, or HS codes.
So the AI reads blue cotton t-shirt and knows exactly what legal code that is in Mexico.
Exactly. It calculates the real-time landed cost, plays the tariffs dynamically, and clears the goods often before the ship is even docked at the port.
It turns international trade law into a background process. The manufacturer in Vietnam just prints a label, and the platform handles the geopolitical complexity.
But we have to acknowledge that the geopolitical complexity is aggressively pushing back right now.
Yeah, we can't ignore the politics of global trade.
And setting the actual politics of global trade aside, purely from a logistical standpoint, the friction between nations is increasing. We are seeing a huge rise in protectionist policies, data localization laws, and intense scrutiny of cross-border data flows.
Especially involving countries like India and China.
Right.
Eh.
And again, neutrally speaking, this presents a massive hurdle. If a nation passes a law stating that the personal data of its citizens cannot leave its borders, a globally unified logistics API suddenly hits a brick wall.
Because a server in Seattle can't process the delivery address for a customer in Mumbai without breaking the law.
Exactly. Amazon, acting as a neutral platform, simply has to adapt its physical and digital architecture to comply. They have to build localized, siloed server farms within those borders.
They have to physically isolate the data.
Yeah, and partner with local entities to satisfy domestic ownership requirements. The platform has to be modular enough to swap out its global routing algorithms for localized ones the exact moment a package crosses a contested border.
The technology can route around a traffic jam easily, but routing around a localized trade embargo requires an entirely different kind of intelligence.
It really does. But here's the thing. Even if you solve the customs AI and you perfectly navigate the data localization laws, you still hit the ultimate undeniable constraint,
The actual physical Earth.
the physical arteries of the planet.
Yes, because robots can't walk on mud. Autonomous trucks can't cross structurally deficient bridges.
Exactly.
The entire deflationary flywheel of physical AI is bottlenecked by the quality of the concrete and the stability of the power grid. And this brings us to the most staggering, ambitious concept in our entire discussion today.
The global infrastructure proposal.
Yeah, the blueprint from the sources for a $50 trillion global Belt and Road Initiative.
It is a profound realization when you read it. To truly unlock the economic potential of physical AI, the physical infrastructure of the entire planet has to be upgraded.
The figure of $50 trillion over the coming decades is vast.
It's almost unquantifiable to normal people.
Yeah, but it represents the capital required to build smart roads, resilient deep-water ports, high-speed rail, and the massive electrical grids needed to charge millions of autonomous vehicles and robots globally.
Right. But when you throw out a number like $50 trillion, the immediate obvious question is, where does that money actually come from?
Right, you can't just print $50 trillion without hyperinflation, and you definitely can't tax developing nations into poverty just to build smart highways for robots.
Exactly. And the Sources blueprint outlines a fascinating three-pillar mechanism to generate this capital organically without bankrupting the very nations it's trying to help.
And before we get into the weeds here, we should probably throw out a quick disclaimer. The sources go into some heavily political economic theories here, right?
Yeah, they absolutely do. And just to be super clear to anyone listening, we're not taking sides or endorsing these policies.
Right, we're just laying out the blueprints exactly as the original authors presented them in the texts.
Exactly. Whether you lean left, right, or center, we're just reporting the mechanics of how the source argues this $50 trillion could actually be funded.
Perfect. So let's get into it. What's the first pillar?
The elegance of the funding mechanism is that it relies on unlocking trapped value rather than extracting new wealth. The first pillar is the universal digitization of land records.
Okay.
To understand this, we have to look at the macroeconomic concept of dead capital.
Dead capital, right? Let's say you have a farmer in a developing nation. His family has farmed a specific plot of land for generations, right?
Yeah?
In the physical reality, he owns it. Everybody in the village knows he owns it. It might be worth $50,000, but he doesn't have a legally recognized, centralized paper title to it. Or Maybe the local registry is corrupt and unreliable.
which is incredibly common globally.
Right. Because he lacks that formal title, the local bank will not accept the farm as collateral. He can't get a $5,000 loan to buy a tractor to increase his crop yield. That $50,000 piece of land is economically dead.
And from the government's perspective, because the ownership is informal, they cannot accurately assess or collect property taxes on it. It's basically an invisible asset.
So what's the solution?
The blueprint proposes utilizing geographic information systems (GIS) mapping combined with decentralized blockchain ledgers to create immutable, universally recognized digital land titles.
By moving the registry to a blockchain, you bypass the corrupt local bureaucracy entirely.
Right. The ledger proves ownership cryptographically. Suddenly, the bank can verify the title instantly. The farmer gets the loan, buys the tractor, triples his yield, and enters the formal economy.
By simply digitizing the reality of who owns what, you instantly unlock trillions of dollars in global collateral.
Trillions. But solving the collateral problem is really only half the battle. If that farmer is now generating more income, but he is operating entirely in physical cash, those transactions remain invisible to the macroeconomy.
Right. The government still can't tax cash transactions easily.
Exactly. This is where the second pillar comes in: universal digital ID and payments.
Which we've actually seen execute flawlessly at a massive scale in India, right?
Yeah.
The Aadhaar identity system and the UPI payment interface.
Yeah, the Indian model is the perfect blueprint for this. Before Aadhaar, hundreds of millions of people lacked formal identification, which completely locked them out of banking and government services.
They were just outside the system.
Right. But by issuing a biometric digital ID and pairing it with UPI, which is a public digital infrastructure, allowing instant zero-fee money transfers from any mobile phone, India basically pulled its massive informal economy into the light.
It eliminates the friction of physical cash. It drastically reduces corruption and leakage in government subsidies because the money goes directly into a verified digital wallet.
And crucially, it creates a digital trail of economic activity.
Which leads to the third pillar in the source's proposal, pragmatic land reform.
Right. Once the land is digitized and the economy is formalized through digital payments, citizens have secure tenure. They transition from being passive occupants of the land to active stakeholders in its development.
Okay, so we have digitized land unlocking capital and digital IDs formalizing the economy. But how does this actually connect back to Amazon and the physical AWS?
Right. Why does a global logistics platform care if a farmer in Peru has a digital wallet?
Exactly. Why do they care?
Because of the symbiotic loop it creates. When you formalize a massive, previously invisible economy, you generate unprecedented organic GDP growth. That growth creates a highly stable, predictable tax base for the government.
And the government uses that newly generated tax revenue to fund the $50 trillion in infrastructure projects.
Exactly. They pave the dirt roads, they reinforce the bridges, they build the high-voltage transmission lines.
And those newly paved roads and robust power grids are exactly what Amazon's autonomous trucks and Optimus robots require to operate.
It is a planetary-scale feedback loop.
It really is. The digital reforms generate the capital to build the modern infrastructure. The modern infrastructure allows the physical AI to deploy globally. The physical AI drops the cost of logistics to near zero, which hyper-accelerates global commerce, generating even more tax revenue to build even better roads.
Yeah. The blueprint suggests looking at China's $1.4 trillion Belt and Road Initiative as a proof of concept for massive infrastructural ambition, but pivoting the execution to be entirely multilateral, transparent, and inclusive.
Again, purely theoretically, according to the author.
Exactly. It's not about one nation projecting power. It's about establishing the foundational operating system for a frictionless global economy.
So what does this all mean? It is an incredible architectural vision. I mean, we've covered an immense amount of ground today.
We really have.
We started with a simple software announcement, ASCS, opening up an API for shipping. But pulling that thread revealed a total transformation of physical reality.
Yeah.
We looked at Vulcan robots learning the tactile difference between glass and steel in real time. We examined how Part 108 regulations turned drones into the physical equivalent of 5G data networks.
The end-to-end neural networks allowing humanoid robots to navigate the chaotic environments built for us.
And we traced how all of this relies on a $50 trillion macroeconomic re-architecting of land and identity to pave the globe.
The underlying current beneath every single one of these technologies is the systematic elimination of physical friction. The hardest part of building anything in the real world has always been the sheer resistance of moving atoms from point A to point B.
That resistance is being completely abstracted away.
Hmm.
If you are listening to this and you're an entrepreneur or a creator, the takeaway is staggering. The barrier between your idea and a global market is collapsing to zero.
It's all software now.
Right. You design the product, you interface with the API, and a highly orchestrated swarm of AI, drones, and robotics handles the physical reality. You are orchestrating atoms with the ease of sending an email.
But, stepping back, this raises a really profound philosophical question about the nature of this frictionless future that we didn't really touch on yet.
What's that?
We are watching the construction of a single, highly optimized planetary machine. A machine where cloud-based AI governs the movement of almost all resources, routing manufacturing and deliveries based purely on algorithmic efficiency, entirely independent of political borders.
Okay.
If a single platform with its AI, drones, and robots ultimately handles the physical movement of almost all atoms across the globe, what happens to the concept of a sovereign national economy?
Wow.
If an algorithm optimally routes global manufacturing, resources, and deliveries independent of borders, do nations simply become different geographic server racks in one giant planetary warehouse? Something to think about.
That is a staggering thought to end on. Are we just inventory locations in the system? It brings us right back to that image at the beginning. You sitting at a coffee shop with your laptop.
Yeah.
You aren't just running a business. You are a node plugging into a global organism that is constantly learning, constantly optimizing, and constantly pushing the cost of physical reality closer to zero. The friction is gone. The era of the physical AWS is here. Thanks for taking this deep dive with us. We'll catch you next time.